Hey everyone, we're so happy to have you here at Nodes 2024. Welcome to the data science track. I am your host of this particular talk today, which is Beyond Vectors. So let's jump right in. So by now, everybody's heard about retrieval-augmented generation. We had some really interesting talks. Sadir was talking about what's being done in that. And even in just the group chat that we just had, the panel session, people are talking a lot about what is going on with RAG and graph RAG specifically. So what I'm talking to you folks about today is how do we leverage data science to continue to improve the retrieval augmented generation that we're working on? There's a lot of work being done in the space, taking us into agentic models and agentic applications. But at the heart of it, we always need to go back to what is the data that's under the hood that's driving these applications, and what can we learn about this to make better responses and better applications. So obviously, we know what retrieval augmented generation is. But when we talk about using a knowledge graph for RAG, the question becomes, what data goes into the knowledge graph? So many people who are doing RAG already are leveraging vector databases, or maybe you've started a little bit with graph RAG. But what we want to focus on here is how can we use the breadth of the data that we have in order to provide the best response within that RAG application. So we are going to talk a little bit about leveraging unstructured data as well as your structured data and your semi-structured data in the knowledge graph. There have been lots of other great talks today about how you produce the knowledge graph and where that comes from. If you want information on that, definitely drop a note in the chat or in the questions. So please, if you have any questions, let us know. So what I want to talk about is, what does it mean? How do we get all that information in there? Where does that information come from, and what can we use? So I'm going to talk through, an example of something that we built internally at Neo4j. You'll see it within our documentation. We had some folks who took a lot of our data sources, which are the documentation of Neo4j, specifically around graph data science, but we also took developer blogs, everything in our community support knowledge base, our GitHub repositories, and we said, okay, if we bring all of this together as a source of information to provide information about the product and questions that people have, what might that look like? So the steps that were taken, first of all, it was split into a 512 chunk size. LangChain recursive text splitter was used. We used the embeddings, ended up using GCP, and there's a URL for each chunk for the LLM citation. So what we did is we took all of those documents, all of the URLs for each of those documents, broke them down into chunks, and fed them into the application. What I want to talk about now is, what does the actual chatbot data model look like? So as I mentioned, over here on the right, we have the URL, which is the original source for the document. We have the document, in this case, I mean chunk. So we have the chunk of that document. And then on the left-hand side, we're going to see the nodes that are related to the application itself. One thing that we're going to see is you've got the session all the way on the left, which is for the user. We have the conversation within that session, and then we have the message. So in this case, message means prompt or response. And we see that from one message to the next, from one message to the next message, we have a relationship next. And among the documents, we also have similarity. So we'll talk a little bit about where similarity comes into play. One of the things that you're going to see also, though, is you're going to see this relationship has context. And what this means is that when the graph RAG application was running, based on that prompt, this particular chunk was retrieved. So when we think about the knowledge graph, it's not just about the data that's under the hood, but it's also about the conversation itself, and how do we leverage the way the application is living and is live to gain more information. So ultimately today, what we're talking about is we're talking about how you can leverage data science and graph data science to improve the quality of your GraphRag application, as well as start to turn it into some business insights and some ROI. I know in one of the earlier keynotes, it was mentioned, we have all these people that are playing with things. How do we get to ROI? Well, as the data scientist on the team, you have a way that you can provide really good insight to the developers. We as data scientists, historically we're used to being the initial point person on AI applications. And now we're really a member of a very diverse team that all work together to build these AI applications. So this is the chatbot data model that we're using as the basis for the conversation today. So what does it mean to have a high quality grounding data set? One of the things that we know is we have the 5 principles of a high quality grounding data set for your RAG application. First, it needs to be relevant. We need to make sure that the data that's in the data set for your application is relevant to your use case. We certainly don't want it to be noisy. You want to make sure that it really does fill in the gap of the LLM's knowledge. LLMs are really good at general information and they're very good at understanding language, but they're not really necessarily good at the specific domain knowledge. And so you really want to look at what is the information and what are the documents that are in most cases either non-public, whether it's proprietary or even just within your stores, that are really going to augment those outputs. We need it to be reliable. You want to make sure that you're getting the right answer at the right time. So if I'm asking a question about a GDS library, is it giving me the information that's relevant to the version that I'm using? Is there a filtering that needs to occur? How do we make sure that we're getting this good, reliable information? Looking at sourcing, the data provenance of what's been coming in. Additionally, we need to look at, as data scientists are always used to, we need to make sure that things are clean. Is it free of noise? Was it generated from notebooks? Is there HTML or websites? As always, you really need to make sure that that data is clean so that we have really strong signal in what's being retrieved. And finally, we need it to be efficient. We need to make sure that we don't have a lot of duplicates or near duplicates, and that we want to make sure that we have really valuable context that's being returned. So let's dive into this a little bit. How can we actually use the tools and the skills that we have as data science practitioners to help meet this threshold for high quality grounding data? Well, as always, we always start with the EDA, right? It's always our first go-to. So for example, in this instance, we're looking at EDA on source documents. So we know that these source documents were chunked into 512 characters. And when we look at the actual text length of each of those pieces, we want to be able to see what are those chunk lengths. And one of the things that we see is anytime you have this long right tail, we know that something has gone a little bit wrong. And so we can see that there was an error in one of the chunking mechanisms. There was an error. So we tidied that up. And then we see this new text length distribution makes sense, right? We know that we have a maximum of 512. We know that there's going to be a variety of pieces, but this is really the distribution that we would expect to see within each of those chunks. So again, go back to the basics of what you know about a quality ML lifecycle, and let's start with the EDA. When we look at EDA from a graph perspective, with graph data science, there's some things that you're going to want to do. One thing that you want to do is you want to start looking at a KNN similarity relationship among the context nodes. So what we would suggest you do is you go through, you run a k-nearest neighbor similarity, and you create a new relationship among those. And this is going to be based on cosine similarity of the embedding of that chunk that's in the node. And then you're going to create relationships. What that will do is it will allow you to get insight as far as community detection and or centrality. Now, as with any kind of, clustering when you're looking at, there are other mechanisms that you could use. You could look at more of a threshold based. So I want anything that's within a similarity of X or something like that. What I would suggest is start with KNN until you have a reason to do something else. Once you do that, you're going to actually be using that document graph, and then you can also use a node embedding if you want. So we already talked a little bit about the embeddings from the text, but just so that you know, if you're not aware, you can also do node embeddings. And node embeddings create a vector of the structure of the node and its relationships itself. So it's another tool that you can use. What's good about this is it allows you to curate the grounding data set for techniques that work at scale. We are looking at masses and masses of documents, and we need to be able to find ways to make really quality underpinnings of these applications with massive amounts of data. So how do we go about doing that? So again, as always, the EDA. So what we're looking at right now is we're looking at FastRP, which is one of the community detection algorithms. And one of the things that we're seeing here is the icon color, the colors of the graph communities themselves. And then additionally, within each of the communities, we've run the algorithm PageRank. And PageRank, as we know, represents sort of the importance or the prevalence of a particular document. Now, of course, as data scientists, you're used to seeing things that look like this. And what we do is we always dive in deep. So let's take a look. You're going to be leveraging everything that you already know about clustering and clustering algorithms to start to understand what's happening within your data. So for example, in this left-hand view, we see a single community document cluster. We definitely see some high page rank. It looks like the margins are pretty clear. If we ran silhouette scores on it, we would probably have like a pretty good view on that. But one of the things that we're seeing on this right-hand side is we're seeing overlapping document communities. And your instincts may say, oh, we have great margins, we have high density, this is great. Maybe. But what you also want to make sure is that we want to make sure that we have a breadth of knowledge. So one thing to be aware of when you see the sort of density in the community clustering from the embedding visualization perspective is, do we have things that are too similar? Do we have redundancies here? Is it that this is really highly clustered because this is a good source of information and it's covering the topic well? Or is it that we have some redundancies? So the first thing we want to do is we want to clean and we want to just get an idea of what are the communities. And remember, these communities are based on the text embedding of the chunk. So really keep that in mind when you're evaluating what you're seeing in the cluster itself. So again, if we want to clean, we want to be mindful of, here we're looking at identifying text errors. So the EDA is always going to be the best place to start. In this particular instance, what we've done is a lot of what you're going to see in these evaluations are looking at the data at these community levels that we've run. So when we look at the median average word length within that cluster, we can see this particular cluster here. Remember when we looked at the EDA of the text length, we saw, a longer left tail and then, high density around the maximum length. Well, what we see here is the median word length is 512. If the entire chunk is 512 and the median average word length is 512, then we need to look at that community and we need to see what's happening. So in this case, it's community 7117. Let's take a look at it. When we dive into that community, basically what we're seeing is we're seeing a lot of sort of like junk data where it's, it looks like it's a JSON of some kind. It doesn't necessarily mean there's a lot of signal in it. It looks like this is something that's probably going to be cleaned out. If this gets returned back to me, it's probably not going to be really helpful to answering some sort of a natural language question. So again, your EDA, looking at the basics, median average word length within each of the communities. The next thing we're going to talk about, and this is going to harken back to what I said about the clustering, is looking at similarity within the text chunk. Now, yes, we created the communities based on similarity and embedding. But the question then becomes, we did KNN. So is it that we're too similar? So one of the things that we're seeing here is when we look at these communities here, we can see these top 6. Those average similarities among all of the documents, this first one, we have 17 documents that have a 99% similarity, 49 documents at 98, and so on and so forth. So we're definitely seeing a lot of redundancy here. So let's dive into those and take a peek. In this particular instance, what we're seeing is that this is one example of this community, 4702, which is the second one listed. And what we see, we've got the URL, and we see that the text chunk is primarily the same. The reason has to do with the way that we build our documentation. We build our documentation so that there's certain general information. So here we're talking about heterogeneous relationships, the algorithm's ability to distinguish between relationships. These are very, very similar. Even though the subtopics and the URLs are different, there's like a repeat of that information. Now, when you're in your documentation, that's great. You want all of that. But when we're trying to return the top K documents compared to my prompt, am I going to get a complete answer? Because really, I'm only going to get one response if they're all the same. So how can we address that? One of the advantages of leveraging Neo4j is you have the opportunity to collapse these duplicate nodes. And what's good about this and using this collapse function within APOC is that you take each of those chunks and you collapse them into a single node. However, you keep the original connection to the URL. So you get the advantage of it being tidy and clean, but you don't lose the context of all the different URLs that gets to. What that's going to allow you to do is, again, you want to get good context back. And so this is going to allow you to tidy that up. The last thing that we're going to talk about is we're going to talk about logging conversations within your chatbot. So one of the things that we need to talk about a little bit is how graphs enable explainable AI. As we're working with these elements, and you've even seen it probably in your ChatGPT when you ask questions, it gives you an answer and it gives you those citations. Where did this information come from? By leveraging this data model, whenever you get this message response, you're going to get the URL of where that information came from. And so what it allows the person to do is it allows the person to either follow up at that citation for more information, dive deeper into something, or just have better confidence that the answer that they're getting in response really is relevant to what they're looking for. So what does this look like in practice? Again, let's think through the data model. Here we've got the session on the left, we've got the conversation that starts, and these light pink elements that you see through the middle are the actual messages. So the first one is the prompt, and then the second one is the response. And what we see in this response is that this response is connected to a number of documents. Each of these darker pink colors is the actual chunk that was retrieved. So we ask the chatbot a question. The response says, based on this question, these are the 10 relevant documents, and provides the response. Then we say, okay, well, that's that answer. This is my follow-up to that prompt, which is this middle piece here. And then based on this prompt, you'll go into the application will go in, leverage RAG methodologies, and come up with now what are the 10 most relevant documents that I'm going to have in this graph RAG application. And so what we see here is a couple of things. One is we see that half of the documents from the first prompt are related to the second prompt. But we can see also that the conversation is starting to drift in another direction. It's drifting into other documents. And so you might be asking like, okay, Alison, well, that's all well and good, but how is this helpful to me? And what does this really mean? I like to think of it in terms of, say, comparing it with Mixpanel. Anybody ever work with Mixpanel, product analytics, anything like that? When you're looking at that, you're able to sort of track through and see how one click leads to the next click leads to the next, and allows you to understand how people are using, say, your product. When we look at the way conversations move, it allows you to gain insight into how are people actually thinking about my product, or how are people thinking about GDS? What does that look like? And so one of the things, and now we're starting to get into what is the actual ROI? What can we glean from this? So here we're looking at heat maps, and let me just take a second and explain to you what you're looking at here. The y-axis, your vertical axis, is each of the different communities of documents. Along the bottom, what we're looking at is we're looking at each of the individual prompts, and based on that prompt, where were the most documents coming from? And what we see is that initially, early in the conversation, a lot of the documents that were being retrieved were around this one particular area of community, this one community of information. But then what we see is as the conversation goes on, it spreads into a lot of different communities. And so the question becomes, like, when we look at these heat maps and we look at these messages, what is it telling us about which areas of the document map people are going to? And this is going to tell you a few different things. It could be that people start in one place and then they go into a variety of different subjects depending on where they want to go. It will also potentially tell you maybe it takes a long time to get to an area of density, or maybe it's going to highlight there's an area of information that we're missing and there's a blind spot. So to really understand that. Sidebar here, if you're interested in building dashboards to track these things, it can be really helpful. There is NeoDash, which is a dashboard, a mechanism that you can use that you can evaluate these things. But let's talk a little bit about what you learn from these conversations. First thing we want to look at is conversation length. When you think about conversation length, if we think about, there's certainly some applications where, your directive is to keep people engaged as long as possible. So I want these conversations to go really long. It's that maybe you're in an eyeballs business, right? Where you want these conversations to be really engaging and you want to keep people there. In our instance, we were trying to answer people's questions about graph data science. So we want those conversations to be short and sweet, to be able to make sure that someone gets in, gets the answer that they need, and then moves on. So how you interpret conversation length analysis is really going to depend on your use case. So are you looking for, like, everyone is in and out in 5 prompts or less, or are you looking for something a little bit longer? So conversation length is the number of prompts and responses. And that's one metric that you can look at to understand how people are leveraging your GraphRag application. Another element you can look at when we think about dashboarding is the LLM response time. Now, this is changing all the time depending on your application, depending on how large the context window is. So this is something, in our case overall, we can see that as the conversation length increases, those conversation response times can increase. And again, that mostly has to do with memory. This is changing all the time. So really take into account the way that your application is built, which models you're using when you're looking to evaluate each of the individual response times over the course of the conversation. But ultimately, what we really want to start looking at is one of the things that we want to look at is understanding how context documents are used. So in this graph, what we see the dark pinks are the actual messages and the prompts that were used, and the lighter pinks are the chunks. And what we find, as we do with all graph, and so again, this is about the live application, the prompts and response, and the documents that were connected to it. And what you find with graph is the natural structure is going to tell you something about what's happening in the knowledge. We see that we have sort of what I call the hub and spokes sort of the satellite pieces where you've got a message and it has some documents that are used, but maybe they're not used in other conversations. This is a very small portion of the graph. But what we do see is these much more higher density areas in the middle. And what that's telling us is that there's lots of prompts and response that are leveraging the same types of documents and the same types of questions. And that's going to tell you a few different things. It can tell you what is the most important or the most common things that people are talking about. It can tell you what are people the most curious about. You know, as someone who's on the enablement and education side, what that's telling me is maybe this is an area where we need to produce more content because there are a lot of questions about this. Or maybe it's our content has been doing really great. Everybody's coming and asking about these elements. So this is wonderful. So as always, how we interpret what we see in the analytics is going to be particular to your use case and to how you're going through things. So if anybody has any questions, please don't be shy. Just drop them in the Q&A. In this case, what we looked at as we went through, so we see that we've got this high density. We see that certain documents are coming up. So we wanted to take a look at which were the most frequently used grounding texts. And what we found was centrality algorithms came up and connectors came up. And that doesn't surprise me because centrality algorithms are really tied to high risk. Risk evaluations, they come up. There's lots of different use cases for centrality algorithms. And always connectors, how do we actually get our data into and out of Neo4j is like a big topic for folks. So all of these things make sense to me as to why these are at the top of our list, but these are things that are worth looking into as you're evaluating how your application is being used. Another thing we did is we looked at the actual most frequent document communities. So not just the individual documents that came up the most, but which communities came up the most. Obviously, the top community was around documentation. That's where people want to go. But what was interesting is that the second most frequent community was made up of text chunks from all of the blogs from Tomasz Bertanek, who's one of my favorite bloggers, who does a lot on Neo4j and has really excellent content. So it didn't surprise us either that that was the second most frequent community that came up. So again, looking at not just the frequency of the document, but the frequency of the communities of documents can provide you with a lot of insight as to how people are using your application, what that looks like, and getting some deeper understanding. So when we look at these things, what it allows us to do, you can take it even a step further where you can actually take each of the messages and responses and start creating similarities among those. So looking at communities of questions can be a really interesting element for you. Sometimes folks will actually use that for sort of pre-filtering. If you've got lots and lots of documents and you've got a question that comes in that's similar to one that's been used before, you can use that as ways to optimize. But looking at the similarities of those questions and messages and responses is another thing that you can use, another way that you can use graph data science to further making sure that you're getting the relevant responses to what you're working on. Now, this again, we're looking at a clustering algorithm, you know, a flat 2D representation. And in this case, we're looking at the clustering of responses. And here, it makes really good sense that we want to see those really well-defined margins. We want to see good clustering, really good density, because what this is showing us is that the prompts and the responses are really well-defined by topic. So this is giving us the questions and answers, the prompts and responses, and really looking at how those are similar and what those communities look like. And this is another place where you can dive into and say, okay, these are the areas of the prompts that are the most similar. These are the hot topics. This is what people are talking about. And it can tell you one of two things. It can tell you, this is great because people are talking about all the things we want them to be talking about, or they're asking about things we haven't thought about. Maybe there's some unhidden insight in what you have that you haven't seen before, and this is a way of exposing that. So again, the last piece I want to talk about really quickly as we close out this 30 minutes is looking at each of the communities and how well the responses are. This is the best blind spot I can focus you on. Here we're looking at good versus bad ratings. We clearly see that community 14685, the good to bad rating ratio is not great at 5 to 4. And so what this will probably be telling you is that either the information in that community might be outdated, or it could be that there's a blind spot there, there's something that's off. So ultimately, what we really want you to leave you with is there are lots of ways that you can leverage graph data science to not only increase your business insight, but also improve the quality of your graph rag applications. If you have any questions, please feel free to reach out to me via email or via LinkedIn. I'm Alison Cossette, and it was great to have you all here today. Enjoy the rest of Nodes.